Okay, everyone. So yesterday we did some exponents things, and today we're just gonna look at log. So you guys know what log is, right? And we can just basically bump and shuffle to go from exponential law to exponential form to log form. So basically, what we're doing is this is our base, right? Our base goes over here in the log form, and our x bumps over there, and this shuffles, which gives us the y when we shuffle, and this is our bumping. Okay, so when we look at this log base 3, 3 is gonna be our base, this is gonna become our exponent, and we have 81. Okay, you can do the same with going from exponents to log. So our base would be log 4, this will be over here, and 2 will be here. So this is not too complicated, but it's a good reminder that this is what we do when we have to go from exponent form to log form. And you might also be given this, that you need to look at some options, like in the word problem questions you are solving using algebra, you'll have to know how to do this. Okay, so I'm gonna talk about how you can put log into your calculator to figure it out. So our common log is usually when we have base of 10. So if you just press log, it'll automatically be log, and you can just put whatever your value is over here. When you're doing natural log, in which we are talking about ln, it's going to be log base ex, where ln it's ln x. When you want to change your base, you're going to do y is equal to math alpha math, or you can simply divide the two equations. So let's say if you have log 3 base 5, you can just do log base 10 5 divided by log base 10 3, and that's possible. Either method works, whatever you remember. Okay, you can try calculating this question on your own using a calculator by using either of these methods. Okay, I'm not going to talk about log regression. I haven't included any of the regression questions in your exam as well, so you can skip that. Now, just remember your x needs to be always positive. If it's negative, it does not exist. Okay, log laws are important. So one important law was that you cannot have a negative value of your x in this case. Okay, if you have log a, that's just gonna be x. So if your base and the thing next to it are the same, it'll just be equal to your power. So in this case, because 2 and 2 are the same, it's just gonna be equal to 5. Another way of thinking about it is because, like, let's convert this into an exponent. Okay, it's gonna be 5 is equal to, actually it wouldn't really work for this, because it'll be 5 log 2 over 2, because you can bump that up, and this is just 1, so it'll be 5 times 1, which is just 5. Okay, so that's another way you can look at it. Try doing this question on your own. Your answer should be n. We talked about changing the values of log. Now you can solve this using a calculator, right, by doing this. Let's talk about some other log laws. When the bases are the same, you just multiply these two terms. Okay, so when you have to figure out an equivalent expression of the log, you have the bases as same and it's being added, you just multiply that. And the same will be true if you were subtracting it. Okay, and we'll talk about it in a bit here. So when the bases are the same, all I need to do is log base 5, 3x times 4, which is log base 5, 12x. Okay, you can try the two questions here. If I were to write log base 5, 42 as the sum of two logarithms, what I need to ask myself, well, I know 42 is 7 times 8, and I also know that it's 7 times 6. And I also know it's 21 times 2. So I can write it as log base 5, 21 plus log base 5, 2. Or I can do log base 5, 7 plus log base 5, 6. Okay. Let's look at when there's division. Now, because there's division, it'll just be subtraction. When it was multiplication, when this was replaced by multiplication, we did log a m times log a n. Okay. So when we do this, it's just gonna be log base 2, 48 divided by 3, which is just log base 2, 16. Okay. Now, if I go back to this question of how you would write log as a sum of two logarithmic function, I can also say differences, right, of log functions. So we know we can do, well, 84 divided by 2 is 42, right? So it'll be log base 5, 84 minus log base 5, 2. Okay, and you can do it that way. Okay, the next law is that you are supposed to okay, the next rule is basically bumping it in front n. This is something I showed you a little bit before as well. So 10 will just bump above and it'll be 10 log x. This is log x half, so you bump it, it's half log x. And then this would be m to the power of 1 over n. You bump that and you get log 1 over n, 1 over n log am. Okay. Now, this question right here, when I have something like this, right, they want me to evaluate this. What I'll do is bump it. 6 times 3 is 18, log 49 over 7, 49, 7. If I need to evaluate what log 49, 7 is, I can put it in the calculator, or what I can do is I can do, well, 49 to the power of what is 7? And that's half, right? So it's gonna be 18 times half, which is 9. Okay. I think that's easy. Now rewrite the following log expression into a single logarithm and evaluate. So my bases are the same. I can do log 5 2 to the power of 2, log 2 to the power of 2. The bases are the same, so it'll be log 25 times 4, which is just log 100. Okay, and I did times because we're adding and we have the same base. This question right here, bump it back. We have log x to the power of 3 minus log x to the power of 4 plus log x to the power of 2. Divide this, which gives me log x to the power of 3 divided by x to the power of 4 times x to the power of 2. Okay, which will give you log. Now exponents, bases are the same, powers get added. X to the power of 5 over x to the power of 4 divide that, we get log x. Okay, you can try doing these questions. Okay, let's rewrite this as a single logarithm as many logarithm as possible. So let's do log x. This is being multiplied, so I know I can use the adding property over here. Log x, b to the power of 2, bump it, it'll be 3 log x a plus 2 log x b, and that's my answer. Try the next question, pause the video. Now, because we're dividing, log 2 a to the power of 3 minus log 2 8 b to the power of 2. Bump that, we get 3 log 2 to the power of a minus 2 log 2 to the power of 8. Sorry, times 8b of 8b. Okay, now this thing is being multiplied, right? So what I could do potentially before doing this step or after doing this step is 3 log 2a minus 2 log 2 8. Now remember, because it's being multiplied, I need to consider the whole thing, plus log base 2 of b, which gives me 3 log 2a minus 2 log 2 8 minus 2 log 2b. Okay, and that's how you expand it. So make sure, like, always check that. Okay, let's move forward. Can do these questions. Okay, they have given the values of log a, b, c, and there are questions given to you. This one will just be log a minus log b. So log a is 6 minus log b is 3, which gives you 3. Let's do this question. Log a b square minus log c to the power of 4 bumps up. This is being multiplied, so we can do log a plus log b square minus 4 log c. Log a is 6 from here, right? Plus this will be bumped times log b minus 4 times c is 2. 6 plus 2 times log b is 6, right? Minus 8, because 4 times 2 is 8. 6 plus 6 minus 8. So 12 minus 8 is 4, and that's my answer. Okay. Solving log equations using algebra. I remember you guys struggled with this a lot, so please pay close attention to this, because this will be used in word problems as well. So when you're solving, make sure you isolate the power on one side of the equation, convert exponent form to log form, and solve the variable. So let's isolate the power in this question. Divide by 81, we'll isolate it. 243 divided by 81 is 3. 81 divided by 81 is 1. 3 to the power of x minus 4. Now, when bases are the same, powers are equal. So here our power is 1, so 1 is equal to x minus 4. Add 4 on both sides, we get x is equal to 1 plus 4, which is 5. Okay, you can try the next question. Now we are going to try the next question using log only. So what we're going to do is, again, do the same thing. Divide by 81. I get 3 is equal to 3x minus 4. Now, to convert this into a log, my base is going to be 3, and I'm going to have 3 over here, because that gets the bump and shuffle thing we talked about, x minus 4. Now, remember, when base and this is the same, it'll just be equal to 1 is equal to x minus 4. Add 4 on both sides. 5 is equal to 5 is equal to x. Now, if you don't remember this piece that we talked about in the video, you can also just put it in the calculator, right? And how would you solve this using a graphing calculator? Well, y1, y2, second, trace 5. And there are so many ways you can check one single question, right? So 3 ways of doing a single question. Okay. Let's do this using algebra. So if I were to convert this into log base 310 is equal to x, log base 10, 3 is equal to x. Now this is multiplied, so there are more things to this, but all you need to do is divide both sides by 3, which gives you 4x is equal to 9. Now we just do log base 4, 9 is equal to x. So there wasn't that many stuff. You just need to remember to divide it by 3, because that's a mistake you guys did do on the unit exam. Now let's try doing these questions. Now all I need to do is log base is 3, 20 is equal to x minus 1. Add 1 on both sides and I get log base 3, 20 plus 1 is equal to x. Same thing over here, log base 5, 104 is equal to 2x plus 1. Subtract 1 on both sides, we get 2x is equal to log 5, 104 minus 1. Remember, this operation needs to be done first and then subtract by 1. Divide both sides by 2 and x is equal to log base 5 of 104 minus 1 over 2, and that's your answer. Okay, you can do these practice questions. Okay, we did not do lesson 9, but the only question we did do in lesson 9 was this, right? And you have done this in exponents as well. So you are given a sample of saliva was taken from a patient and it was determined that 387 cells of bacteria were present. If this particular stain of bacteria doubles every 5 hours. So think about how you would do this question. Can you make an equation? What do you think? You can make an equation. Do you guys remember we talked about y is equal to a times b t over p? We did that yesterday. Period is p. T is the total time we take. B is if it's doubling or not. A is your initial amount of cells, and y is what you're calculating. So in this case, this is our A, this is our period, and this is our B because it's doubling, right? So after 24 hours, that means our time is given to us. So we're going to do y is equal to 387 times B is 2, and that's doubling t over 5. So that's an equation. I'm going to replace my t with 24. Okay, so 24. Put that in the calculator basically, and you'll get y is approximately 10,781 cells. Okay. Determine the length of time it will take for this sample to grow to 5,000 cells. Well, this is cells, right? We know this was time is our x. So the y is going to be number of bacterias. Okay, so 5,000 is our y. I'm going to replace it in my equation. 5,000 is equal to 387 times 2 to the power of t over 5. I don't know what my t is really. Okay, so I'm going to solve this. you guys have learned how to solve this, right? So it's gonna be divide by 387. This is what we just did. Okay, so when you divide it, you're isolating your power. So you have 5,000 over 387 is equal to 2 to the power of t over 5. Now I can convert that into a log form, right? So I do log base 2 because that's my base of 5,000 over 387 is equal to t over 5. Now I put this in the calculator, and you should get 3.6915, so on, and it's equal to t over 5. So I just need to multiply both sides by 5, right? Multiply it. 5 divided by 5 is 1. T is equal to 5 times 3.69, which is 18.5. And that's my answer. Okay, so we also did these type of questions yesterday in class, so this should be good. We did not do any other questions in lesson 9. For lesson 10, the main idea was using this formula. M is equal to log I over I naught. And if you need to figure out how many times an earthquake was intense, you can just do 10 to the power of the difference in the magnitude. So in the first question, the difference is going to be 8.1 minus 6.9, and we can use this formula to figure it out, to figure out the intensity. Then we did some pH questions. If it's below 7, it's acidic. If it's above 7, it's basic. And this is a formula you'll be using for it, negative log H3O plus. And then if you need to do the reverse, it's going to be H3O plus is equal to 10 to the power of negative pH. Again, if you need to figure out more acidic, it's going to be the difference of the pH. Okay. I hope this helped.